Hello, I'm Paco Muñoz. Let me explain the tar queue in the JavaScript programming language. The goals of this presentation are to identify how and when asynchronous activities, that is, event arrivals, are run in the JavaScript programming language. The contents of this presentation are structured as follows. Let's start. In event-oriented programming languages, like JavaScript, event arrivals generate new activities. But we have a problem here. Why? Simply that we have a single thread of execution in our process. So, if we are creating a new activity each time an event happens, then we have at least two ready activities. The currently running one and the newly generated one, and they compete for the processor, so we should give priority to one of them, and the election is that we give priority to the currently running activity. So that currently running activity isn't interrupted. As a result of this, these new events should be kept somewhere. So, those event-generated activities remain in a pending state in a logical data structure that behaves as a queue. So, they seem to remain enqueued and will be progressively started when? Simply when the currently running activities are completing their execution. So, once the currently running activity is completed, we then consider the next one in the pending queue. And this is generating a turn queue. So let's explain this turn queue in detail. So, a turn queue is simply a data structure that maintains the actions to be run, and those actions are associated to the arrival of new events, either internal or external to the process. This follows the guard action model. In that model, we have a guard that in the common case will be the event arrival. But in the logic of algorithms, this event arrival should be considered as a precondition to be satisfied in order to run its associated instructions. So, an event arrival is logically a precondition that should be true in order to run a given sequence of instructions. And that sequence of instructions is the associated action to that guard. And in our case, those instructions will manage the event. In the case of the JavaScript programming language, that action is implemented using a callback. So, all the activated callbacks, that is, all callbacks that are associated to true preconditions, are maintained in this queue, in this logical queue, in the turn queue. And as already said, they will be run when they become the first element in the queue. That is, when they get that first position and there's no other currently running activity. So, let's consider the following example. We have here on the left a short JavaScript program. It defines the recursive Fibonacci function. It uses a showMessage function that shows a message on a screen using to this end two arguments. The first one is considered a prefix in the message, and the second one is presented as the result of a previous step in the execution. Later on, we will show a given sequence of messages. Let's follow its trace in order to see which are the contents of the turn queue and when each one of those events has been generated. So let's assume that we have started the process. To this end, we are using the node command, and we are passing as an argument the name of this program file. So the interpreter reads these functions and finds that this is the first instruction that provides a given output. In our case, the currently running activity is executing this line and shows on screen this message starting the process. Later on, it gets this other block, the setTimeout. And setTimeout is programming in 10 milliseconds the execution of this callback. So this corresponds to a new event, the execution of this callback. And the corresponding event is placed in the turn queue. Why? Because we have another thread of execution, the main one, that is running all the instructions in the main program. Here, indeed, it has executed the setTimeout call. And the callback is simply placed in the turn queue. And it will be put in the queue once this interval has been elapsed. That is, after 10 milliseconds, and only at that time. Let's continue. The execution gets to this line, and it calls the Fibonacci function with an argument of 40. Well, this demands a long interval to be completed. So, in the interim, the M1 activity has been placed in the turn queue. Well, and the main thread gets to this line and shows this message. So on screen the user may see this line. And finally, the main thread gets to the last block, and in that last block it is programming in 1 millisecond the arrival of this event that will execute this function. But it becomes ready and it is placed at the end of the turn queue, where we may find another activity in a pending state. So at this point the main thread completes, and that currently running activity will finish. So now we have this callback as the first element in the turn queue. And as a result of this, we may see this third message on screen. That was this one, that indeed was found in the second place in our execution, but it was placed in the turn queue at that moment. As a result of this activity completes also, and now this last one that responsible for this message is the currently running one and the unique one in the turn queue. And with this we show this last message. And this is the correct sequence observed in our process. We have seen in this example that each one of those instructions, of those calls to setTimeout, is placing another activity in the turn queue. But those activities aren't executed immediately when this time interval has happened. They are simply placed in the turn queue at that time, not before. And in this case, the process has needed a very long interval, depending on the capability of our processor, in order to reach the first position of that turnkey. Well, and eventually the process is completed. Let's conclude. Once this presentation is ended, the students should be able to identify how and when asynchronous activities are run in JavaScript. Thanks a lot for your attention.